Welcome back to the AI Frontier podcast. Today, we're diving deep into a groundbreaking paper that tackles a critical challenge in the world of large language models, or LLMs, their memory footprint. Joining me are Dr. Suyu Jay, a PhD candidate at the University of Illinois Urbana-Champaign, who's led this exciting research, and Dr. David Lewis, a professor of computer science at Stanford University, offering his expert perspective. Suyu, tell us, what's the main problem we're trying to address with this paper?
Thanks, Amelia. So LLMs have revolutionized AI, but running them can be expensive, especially as they get larger and more powerful. The issue is that these models require a lot of memory to process information and generate text. This puts a significant strain on the resources available, especially in real-world applications.
It's like trying to store an entire library in a small apartment. You just don't have enough space. That's why optimizing LLM memory efficiency is so crucial, right, David? Absolutely, Amelia. Imagine you want to use a cutting-edge LLM to power a customer service chatbot or an intelligent writing assistant. You'll need to run it on a server that can handle the memory demands. But if the LLM is too memory intensive, you'll need to invest in powerful and expensive hardware. This makes LLMs less accessible for many businesses and researchers. So, that's where your research comes in, Suyu. Can you explain the novel approach you've developed to tackle this memory challenge?
We've created a method called FastGen, which uses a technique called adaptive key-value cache compression. Think of the KV cache as a temporary storage space within the LLM, where it keeps track of past information, like a bookshelf in our library analogy. Instead of storing all the information on the shelf, FastGen strategically removes less important data, freeing up memory. This way, we can make the model more efficient without sacrificing performance.
That's a great analogy, Suyu. David, how does this approach differ from traditional methods of memory optimization in LLMs? Previous approaches often rely on generic compression techniques that treat all information equally. FastGen is smarter. It looks at the structure of the model's attention mechanism to identify which parts of the KV cache are truly essential. Think of it as a librarian who knows which books are frequently used and which ones can be stored in a less accessible location. It's this targeted compression that makes FastGen so effective. So, you're essentially making the LLM smarter about how it uses its memory, like a librarian strategically organizing the library. This is fascinating. Suyu, can you walk us through how you actually implement this adaptive compression?
Sure. We use a process called model profiling. We analyze the model's attention mechanism, which basically reflects how the LLM pays attention to different parts of the input text. Based on this analysis, we identify patterns and decide which parts of the KV cache can be compressed without losing much information. This profiling process is done only once at the start, and the information is used throughout the inference process.
This sounds like a very efficient method. David, what are your thoughts on the feasibility of this approach? Are there any limitations or challenges we need to consider? It's certainly a promising approach, Suyu. However, we need to consider whether these attention patterns are consistent across different LLMs and tasks. If the attention structure is very dynamic and changes significantly, then the profiling process might need to be adjusted more frequently. Also, while the profiling overhead seems minimal, it could become a bottleneck for real-time applications with very stringent latency requirements. That's a good point, David. Suyu, how do you address these potential limitations in your paper?
We've conducted extensive experiments on various LLMs and benchmarks to evaluate the robustness of FastGen. Our results show that the method works remarkably well across different model sizes and tasks. While we acknowledge the potential for further optimization and refinement of the profiling process, our findings suggest that FastGen is a very practical and effective approach to improving LLM efficiency.
Let's dive into the results. Suyu, what kind of memory reductions did you achieve with FastGen?
We found that FastGen can achieve substantial memory reductions, sometimes as high as 40% for the largest LLMs, without any significant drop in the quality of the generated text. This means we can run these powerful models on smaller and less expensive hardware, making them more accessible to a wider range of users.
That's incredible. David, can you put this into perspective for our listeners? What kind of impact does this have on the field of LLMs? This research is very exciting, Amelia. It pushes the boundaries of what's possible with LLMs. By reducing memory requirements, we can make these powerful models more readily available for researchers, developers, and companies. This could lead to a surge in innovation and adoption of LLMs across various fields, from scientific research to creative writing to customer service. Imagine a world where anyone with a laptop can access the power of a state of the art LLM. That's the kind of impact we're talking about. Suyu, what are your plans for further research on FastGen?
There's a lot of exciting work ahead. We're currently exploring ways to optimize the profiling process even further and integrate FastGen with other efficiency techniques like model quantization and distillation. Our goal is to make LLMs even more accessible and efficient, opening up new possibilities for innovation and creativity.
Suyu, David, this has been a fascinating discussion. It's clear that FastGen is a significant step forward in making LLMs more practical and accessible. We've explored its innovative approach, analyzed its impressive results, and discussed its future potential. Thanks for joining me today and sharing your insights.
Thank you for having us, Amelia. It's been a pleasure to share this research with your audience.
My pleasure, Suyu. And thanks to you too, David. This paper provides a clear roadmap for making LLMs more efficient and affordable, driving even greater adoption and impact on the world. Stay tuned for more exciting advancements in the field of AI.